How does speed of light limit global data transfer? Imagine trying to send a message across the world and knowing that no matter how fast your internet is, there's a hard limit on how quickly that message can arrive. That limit is set by the speed of light. When we talk about data traveling across the internet, especially through fiber optic cables, it's not instant. Light in a vacuum zips along at about 300,000 kilometers per second, but in fiber optic cables, it slows down to roughly 2/3 of that speed. This slowdown is because of the glass or plastic material in the cables. This physical fact creates a minimum delay, called latency, which is the time it takes for data to go from one point to another and back. Even if all other parts of the network are perfect, this limit still applies. For example, sending data from New York to London involves thousands of kilometers of fiber. The signal can't travel faster than the speed of light, so there's always a delay. This delay can be around 50 milliseconds for a round trip, which matters a lot for things like video calls or online gaming, where real-time responses are needed. The routes that fiber optic cables take also add to this delay. These cables don't go in straight lines. They often detour around natural obstacles, cities, or infrastructure. This means the actual distance the data travels is longer than the straight-line distance. Internet exchange points, or IXPs, are places where different networks meet to exchange traffic. They help reduce the number of hops and the total distance data has to travel, but they can't change the fundamental speed limit set by light. Scientists and engineers are working on new technologies to get closer to this speed limit. Some new fiber cables can transmit data at speeds very close to the speed of light with very high bandwidth, allowing 4 trillions of bits of data per second. Wireless methods like microwave or laser links can sometimes be faster because light travels slightly faster in air than in glass. But these methods face challenges like needing a clear line of sight and higher setup costs. So, in the end, the speed of light acts like an invisible barrier on how fast data can move around the globe. No matter how advanced our infrastructure gets, this physical law keeps a cap on how quickly information can travel. That's why even with the best routes, the fastest cables, and clever traffic exchanges at IXPs, there's always a tiny delay. Understanding this helps us see why internet latency exists and why efforts to improve speed focus on smarter routing and better technology, rather than eliminating delay altogether.